Okay, in this video I'm going to show you how to actually do that long division we talked about in class. Make sure this is big enough. Alright, this is big enough. For example, u and v are the two Cartesian equations and there are parameters involved in like this. Okay, then we want to look at this as a polynomial in t and treating u and v it's constant, and if we constantly divide each other, and you'll be able to get rid of this t and end up in u. And why that is set had to be set equal to 0 is something that you have to think about. I explained it in class and during the lecture. So first I'm going to go write down the first polynomial. Okay, I wrote this polynomial and set equal to 0. So whatever the number you're looking at in t and u in here, that makes them 0. And this one also solved to the 0. So this is set equal to 0. So here the coefficients are ugly. So let's say I'm dividing this one, that's the dividend, comma, and that's the divisor, and put it in there, and a comma in there. And then you have to let the Mathematica know what your main variable is, which is t here in this case. So make it bigger, doesn't make any difference. So with 150. So if you do that, it's going to divide this polynomial by that polynomial with the main variable t, and it's going to give you the remainder. Remember, in our division process, all we care is the remainder, so I'm going to write it down here like this. All right, I got this polynomial, so I'm going to copy it down in here again. So that's something we got, recorded it. This is set to be 0, and that's set to be 0. If you look at that statement about the dividend is a quotient times the divisor plus remainder, these two forces this one to be also equal to 0. Okay, so we got this new relationship. These two things makes this thing equal to 0. So if you divide that one by this, and the remainder again is set equal to 0. So I'm going to do that in the next line. So I did that. Our divisor was here, although it's written backward there. Our divisors here, this divisors go in here, and then we have a new divisor that becomes dividend, and there's new divisor. Right, degree 2 divided by degree 1 makes sense. If it's the same degree, you can still divide it. But I chose this order so that 16 is slightly smaller, but it didn't make much difference. It still have this ugly coefficients. Now we do that, and we have this next level of ugly part, and that's the next guy. But you can already see that this remainder, if these two things are originally set equal to 0, that makes this remainder 0. If you paired up these two things set equal to 0, you can come up with this one is remainder 0. Okay, if you look at this remainder, there's no t anymore. So this is supposed to be 0, and that is the Cartesian equation it derives. So I'm going to show you on how this one looks like. So I typed up here, and b is some size that I'm going to change later so that we can take a better look about this curve. So here's the equation. I just copied and pasted and added this set equal to 0 part. Alright, so I just did number to 8 so that I can enter it a little bit better. So that seems like a Cartesian equation, and the parametric equation we get out of that is exactly that, and this Cartesian equation didn't seem to actually pick up an additional portion, but that could have been over there and when we change this one here. Let me go ahead and change that. Right, I changed to 50 and it still is not picking up. There's a way to actually do this algebraically to manipulate this one so to make sure that no other parts is appearing. But again, like I said in general, like I said in class in general, this Cartesian equation might pick up additional portion, but definitely the parametric equation must be part of this Cartesian equation. So that parametric equation have this ugly Cartesian equation.